Y'all have a lot of questions about server components, and I get it. It's a really different model, especially if you're already familiar with React, and obviously if you're not. I think it's important that we break down the very core of how they work and how they differ from the existing React model. Thankfully, Josh Comio wrote an article doing this, and I spent the last hour going through it piece by piece, recreating a bunch of the examples and breaking down how server components work on a fundamental level, while also answering tons of questions from people in chat. So hopefully you can find some value in this long rant, because I put a lot of work into it, and I think it's a pretty good one. So without further ado, let's dive in. Thank you, Josh Comio, and thank you, Igor, for sharing this earlier. Making sense of React server components. So here's something that makes me feel old. React celebrated its 10th birthday this year. This is also interesting on my behalf because React started in 2013, but I started writing React in 2018. So I'm now square at the halfway point for React. I have now been around for exactly half of React's journey. In the decades since React was first introduced to a bewildered dev community, it's gone through several evolutions. The React team has not been shy when it comes to radical change. If they discover a better solution to a problem, they'll run with it. A couple of months ago, the React team unveiled React Server Components, the latest paradigm shift. For the first time ever, React components can run exclusively on the server. This word exclusively is important here because this is a part I think people seem to miss a lot. I know I did initially. With things like Remix or Next, your code would run on the server, so you'd send HTML down to the user, but you would also send the JavaScript too for all of the same content. So you were required to then also rerun that JavaScript on the client to recreate the DOM to link the virtual DOM to the real DOM. And because of that, any code in your component that runs on the server is also running on the client. The beauty of the new model is a component by default only runs on the server and doesn't send JavaScript to the client anymore, which is really interesting. There's been so much frigging confusion about this online. Lots of folks have lots of questions around what this is, how it works, what the benefits are, and how it fits together with things like server-side rendering. I've been doing a lot of experimentation with server components, and I've answered a lot of my own questions. I have to admit, I'm way more excited about this stuff than I expected it to be. It's really cool. So my goal today is to help demystify this stuff for you, to answer a lot of questions you might have about server components. To put React server components in context, it's helpful to understand how SSR works. If you're already familiar with SSR, feel free to skip to the next heading. This is what I described before. The user would receive, this is the good old empty HTML file that I talk about a lot with just the script tag. And then the script loads, runs, and then you finally get page content. Yeah, this just explains the bundle. It gets mounted, includes React and other dependencies. Once the JS has been downloaded and parsed, React springs into action. But this all happens when you're staring at a blank white screen. Or if you put some default styles in here, which almost no one does, you have a tiny bit of additional content. Some sites like Twitch have a crappy skeleton that is the default HTML, and then the script comes in to take over. But this is all the user sees for a while. And this is usually not the content you want the user to see. And depending on if they have JavaScript enabled or not, how fast their internet connection is, how fast their device is, and so many other things, that might be a long time they have to sit there and wait for. What SSR does is it does that first run of the JavaScript on the server so that you get sent more useful HTML content. It is not the HTML that includes just that JavaScript tag and nothing else. It's instead the HTML after React does its first render and update. But then you have to get the JavaScript to work, and that's hydration, which Dan Abramov describes as watering dry HTML with the water of interactivity and event handlers. So you have your static HTML with a bunch of elements in it, and then React has to run the way it always does to figure out which elements bind to which components so that it can continue to own and update that HTML page. Once the JS bundle has been downloaded, React will quickly run through our entire app, building up a virtual sketch of the UI and fitting it to the real DOM, attaching event handlers, firing off effects, etc. That's SSR in a nutshell. When we talk about SSR, we typically imagine a flow looking like this. User visits a site, Node.js or something like that receives the request, renders the React application, generating HTML, sends that HTML to the client, and then the client takes over from there, hydrating and rendering. But there are other ones where, what are they specifically explaining here? HTML, when we build the app, yeah. So you can also, at build time, generate different HTML files for every route, and then load JavaScript to take over once the page has been fetched. But usually what we're talking about with SSR is the server side part. This would be more like using the next export function, which I've argued against many a time. Next export should not exist because most of Next's features, especially now in the server component world, require Next's server and its relationship with the client. And if you throw that all away for static HTML files, it's no longer really Next.js. The way I see it, server-side rendering is an umbrella term that includes several rendering strategies. They all have one thing in common. The initial render happens in a server runtime like Node using the React DOM server APIs. Yep, this is very fair. Server-side rendering always means running something like React DOM server on something that isn't the client. But usually what we're referring to is this pattern, bouncing back and forth. This is about data fetching. Using something like React Query or SWR or Apollo, the client will make a network request, which will then grab data and send it back. So this is just what happens if you use fetch at all. But with these tools, you can cache those calls better, prevent having to dupe them, and a lot of other useful, important things. Yeah, server sends files to the client. Well, it sends an HTML file to the client, which then has to download the JavaScript, render the shell, request more data, which goes to the database. Well, it goes to the server that then goes to the database. And then that comes back to the user as JSON, which then can be rendered by the JavaScript to make HTML. There's actually a lot more steps here. I like that he simplified it, but this really like he went out of his way to simplify it here. There's like 7 steps where each of those arrows are. Represent an imaginary made-up timeline. Everybody gets so mad at me when I do stuff like this. Fuck them. It's really helpful. I think this is a good thing to do. It makes it way easier to read and parse. First graph shows the flow using a client-side rendering strat. Starts with the client receiving HTML, then it's to download with a script tag, run, yada yada. We've explained that enough times. You've seen this for a lot. Airbnb starts rendering a shell. Or, one I was mentioning before, we'll turn my network speed down to slow 3G. We're going to go to Twitch, see all of that with the loading spinner and this stuff all here. That's all happening while the JavaScript gets fetched and then runs. So in some amount of time, once the like 20 megs of JS finish fetching, I picked slow 3G for a reason, we'll finally have some JS running in the next couple minutes. Yep, now the JavaScript has started to run. But you see there specifically, before the JavaScript is here, it has this state, because right here it's fetching all of the JavaScript. So this is just the static HTML. Anyways. The user will see the loading state until the network request resolves and React re-renders, replacing the loading UI with the real content, as we just saw with Twitch. Let's look at another way we could architect this. Server, client, yeah. Server renders the shell, so there's some work being done here. So there's more time until the client gets their first response, but less time until they see something valuable. But then they still have to do the same download.js step, the same hydrate step, the same database query, and the same content render. A shell is better than a blank white page, but ultimately doesn't really move the needle in a significant way. Yep. Totally agree. This isn't useful because it makes your site faster. This is useful because it allows you to have a better loading state and better like default templates, depending on how much of your shell you choose to render. So here is where he puts flags for time to first paint and content painted. These are the flags that you'll see in things like Lighthouse and other performance testing tools where it labels different points in the user's journey when the page loads. If we render a blank HTML page that then loads JavaScript to trigger loading states and then get data. Once the JavaScript loads the loading states and has rendered those on the page, we hit first paint because that's the first time content of meaning has been painted on the page. Once the server has sent back the JSON response and we've parsed that and made that into HTML with React, then the content is painted and we hit that flag. So the difference with SSR is that first paint happens much earlier. We get some content way earlier. And the page interaction still has to happen like after the fact, and then the database query, and then the content is painted. But we get something to the user earlier at the cost of a slightly later page interactive, depending on if this render shell is statically cached on the CDN or not. But it's fair to say it's basically the same thing and just first paint is moving. I can agree with that. Doesn't this feel a bit silly? When I look at the SSR graph, I can't help but notice the request start on the server. Instead of requiring a second round trip, why not do the database work during that initial request? So why not fetch these things immediately and then the page will become interactive later. So you have content painted before you have page interactive. This is what like deep SSR does. When you fully SSR the page and its content, you're able to send the correct page down first try with none of these additional states at the cost of additional time until the user sees anything. I was hoping you'd have the interactive chart again because the catch here is that your first paint gets delayed based on how long it takes to do these things. So if your database query takes 5 of his imaginary unit, you just delayed the first thing the user sees by that 5 amount. So if you want the user to see something and you're okay with the right thing, the right content coming a bit later, it is very nice to do this later. But if you want the user to get the correct content first try as fast as possible, then you would do the database call on the server. The problem is, depending on the SSR model you're using, this can be really easy or really hard. It gets difficult to say, hey, I actually want this section to be loaded on client and next section to be loaded on server. And if you change your mind down the road, it can be really painful. This is the beauty of the new model, which I'm sure we'll go into in a bit, especially when streaming gets involved. First paint, content painted page is directive. Yep. Instead of bouncing back and forth, we do our database query as part of the initial request, sending fully populated UI straight to the user. How we do this? We need to be able to give React a chunk of code that runs exclusively on the server to do a database query. So this hasn't been an option, even with SSR. Kind of with something like TRPC, you could actually specify that a query is SSR ready. And when it does the server-side render with that hook, it can block, get that data, and pull it in on that first render. So there are solutions before server components that let you on server's pass, run server code, and on the client's pass, fetch data from server. This has been figured out. We have had solutions. I'm not going to say they're anywhere near as good as RSC, but we did have this option in React. Because yes, components render on both, but you can have the code that they run trigger differently depending on which environment the code is running in. But I'm going to say this. We've come up with lots of solutions. Next and Gatsby have created their own ways to run code exclusively on the server. I should have just scrolled down. Get server-side props. This code only runs on the server, and then when you access it on the client, it's data that exists in the top-level props route. I will say get server-side props is one of like the worst patterns I've ever used, and I'm so happy it is dead because this encourages terrible things. It's like that awful pattern of wrapping your app with context, but 10 times worse because there's no type safety, there's no inference for anything, and you have no guarantees that the props you return here actually make it to a component anywhere in your application because this is defined route level and things have to be passed through. So your components underneath don't actually know if they have access to this. Regardless, it worked, but wrappers like TRPC doing this at a different level ended up being a much better experience in my opinion. I have a whole article on my blog that I never plug. One of my first articles that did really well, and I'm proud as hell of this one. An Inconsistent Truth, Next.js and Type Safety. This article is not the case with server components, but if you're still using PageRouter, is specifically if you're using get server-side props, it's so bad. Next can be a type safety risk. We have this get server-side props that returns user, and then we call props.user.name. But if we do anything between these two, which there's a lot of room to do, this data might not make it here. In particular, if the document or app TS or JSX files don't pass props properly to the page component, this won't come through. If these are in different files, you have no guarantees. And this doesn't actually have a type definition at all. This is all coming off of any. As I said here, there's a number of type errors this silently allows. If you modify the schema, you select different values in that Prisma call, you change the key, erroneously delete something. For some reason, they use implicit any for all of this stuff. We can manually type the props, but then they can still drift. So here I only select ID, even though we think we have the whole type. That fails. Their infer get server-side props casts a bunch of shit to any. Yeah, it's overrides to key string any, which is awful. It also infers to props never. And we've thankfully moved on. So yeah, I have a whole article about that if you want to learn more about the type level failures within get server-side props. There's also structural issues for how it gets called and where data goes. But there's a reason that Next has moved on to something much better. Yeah, GSSP was a mess. They were just super ahead of its time. Let's see if we agree on the problems. Only works at route level. Yep. Meta Framework came up with its own approach. Gatsby. Yep. All React components will always iterate on the client. This is nothing about the misery that is the type safety story. Regardless, it was awesome that we had a solution. Caught on for a reason. Next blew up before RSCs were even a thought. And that's because of how much better these patterns were than having to fetch everything on client. But here's where stuff gets interesting. Server components, the thing you click the video for. At a high level, React Server Components is the name for a brand new paradigm. In this new world, we can create components that run exclusively on the server. So allows us to do things like write database queries right inside our components. I remember the first time someone posted an example like this, everybody was freaking out like, oh my God, you're gonna allow so many SQL injects, sending that code to the users, because it was so hard for us to comprehend that this code only runs on the server. This is the equivalent of in something like Rails defining a template. This only runs on the server. This file effectively is an HTML template generator. That is the magic of RSCs, is you have an HTML template generator interoping with React, the client library, and you can move between the two as you please. Yep, he even said, as I was saying before, this code looked absolutely wild at first, and it did. It took me a bit to process that this only ran on the server. Function components can't be async. We're not allowing them to have side effects and render like that. This is an important piece. Server components never re-render. This code breaks the traditional React model in that sense. Like, this code code will not rerun when you re-render on client. And if you have a client component that was passed the server component as a prop that it renders inside of it, and then that client component re-renders, that child won't re-render. That's a huge win. And if you do get an update from the server with new markup for those server components, it can render those through React with something like router.refresh in Next, which allows you to directly update those static, non-updating components when the server sends updated HTML. This means a big chunk of React's API is incompatible with server components. You can't use state. You can't really use React context. You aren't going to run something like a use effect as a side effect. There really aren't side effects in server components, which is nice too. Because I found a lot of the time we're bringing in things like use effect and other side effects, it's to get data to our components, which is a significant portion of why we have side effects in our apps. So if we have a different way to get that data without needing side effects, that is a win, even though when you first look at it, it might feel like a cost because now we have part of React where we can't use the solutions we're used to. That's because it lets us not reach for those solutions when we don't need them yet. Server components themselves are surprisingly straightforward, but the React server components paradigm is significantly more complex. This is because we still have regular old components, and the way they fit together can be pretty confusing. This new paradigm, the traditional React components we're familiar with are called client components. Yep, I've been shitting on this name forever. Should have been interactive components. Server components only render on server, client components render on both. Here's how I summarize it. RSC is the name for the paradigm. The standard React components we know and love have been rebranded as client components. It's a new name for an old thing. It works just like client components worked in Next and Remix before, where they run on both server and on client. New paradigm has a new component type called server components. These only run on the server. The code isn't included in the JS, and they never hydrate or re-render. Yes, this is the distinction. I'm gonna just hold and let y'all look at this and read it a few times. If you don't get it yet, pause and think a little bit longer on it. This is the core of server components. It's important that we understand the way things worked before. That is client components, and server components are this new thing that doesn't follow the model we're used to. They don't run in your client. And we can interop between these things the way we would before with a template that runs in a server that then triggers JavaScript on the client, but with a much happier story relating these pieces. React server components are not a replacement for server-side rendering. It's SSR version 2. Two separate puzzle pieces, yeah. We still have server-side rendering to generate the initial HTML. It still runs your client components once to make that proper scaffolding, but a lot of the content can be fetched as server components, and you don't need a lot of those behaviors on the client. You don't need to make those API requests. You don't need to do a lot of those things. Yeah, they even have RSC examples without SSR, which means similar to with SSR, where you could use it as a build step, you can build the React server components ahead of time and have those be fetched effectively from a CDN to hydrate your app. It's just a weird pattern. I haven't seen a compelling use case for it yet, but I could see them in the future for sure. Compatible environments. Traditionally, you could just install the latest React version to try out a new feature. Server components are not that simple because it has to be integrated with a lot of things. It's the bundler, the server runtime, the relationship between those. There's a lot of pieces that have to be assembled just right for this to work. He says here, the only recommended way to start with RSCs right now is to use the newest version of Next 13. Hopefully in the future, more React-based frameworks will start to incorporate server components. Feels awkward that a core React feature is only available to one particular tool. The React docs have a bleeding edge framework section where they list the frameworks that support server components. Actually curious what's on it right now. Not recommended for production as of March 2023. I wonder how salty the team is on that. They don't have anything else under here yet. That's not surprising, but interesting regardless. I'm excited to see more frameworks using server components. I know Remix is working on it. I believe Astra was for a bit. I don't know how much of a priority that is at the moment, but there's a lot of places trying to make good server component integrations in their frameworks. In the new React server components paradigm, all components are assumed to be server components by default. This was a controversial decision that I think was the right decision. And as he says here, if you want the old behavior, you want a traditional client component, use client. If you move all of your code from pages directory over to app router and you want to just have everything work the way it did before, you can code mod, go add use client onto every TSX file, and it will behave the exact same way as it used to, which is really powerful. But the server components don't have those behaviors, and you can fetch directly within them. Really, really powerful. The standalone string at the top, use client, is how we tell React this component is client components. We don't need to specify use server in our server components. Use server is used for other things, which we'll get to in a while, but for now, use client, it's similar to use strict for strict mode JavaScript, but they're trying to follow the way these things have been done before. So which components should be client components? I like this framing. If a component can be a server component, it should be a server component. And that's why it's the default, because server components are much simpler and easier to reason about because they don't rerun. You don't have to mentally keep track of logic updates and state. It just renders the right stuff. It's almost like previously with function components before hooks, you always wanted function components if you could because they were SFCs, stateless functional components. And when you don't have state in a thing that you don't need, it becomes much simpler. This is also why HTMX is so dope, because it significantly reduces the amount of state you're thinking about managing and interacting with in the client and in your code. Less state is good. And I think that's a theme you're going to see with a lot of the technologies that we'll be talking about and building over the next few years. This is the anti-state and kind of the anti-API wave that we're seeing happen. We're talking about like page interactive time and stuff here. It is cool to send less JavaScript, but like less state is good because less state is less surface area for problems. We also shouldn't make it our mission to eradicate as many client components as possible. We shouldn't try to optimize for smallest number of client components. It's worth remembering that until now, every component in every app has been a client component. And it absolutely makes sense to have a lot of client components still. And if you have something where like you have one client component and you could break it up into two to make it easier, you should. And if you have a server component and it needs some behavior that is better to do on client, you should move it there. Yep, that's all stuff I agree with. Boundaries. One of the first questions I had when I was getting familiar with RSCs was, what happens when the props change? For example, suppose we had a server component like this. Suppose the initial render hit was 0. Component will produce the following markup. What happens when hits change? It would need to re-render, but it can't. Server components don't make sense in isolation. This is, I think, the part that is making it harder to digest server components. With hooks, you could start at any point in your app. You'd be like, okay, I'm going to add this component here, and we're going to use hooks for it. And it would just work in an old React app as long as you update the React version. With server components, it only works from the root. So that top level mounted component, the thing at the very, very top of your DOM, that has to be ready for and support server components. And as you add RSCs and these patterns throughout your app, it has to start from the root down. So it's not anywhere near as easy to adopt or even think about, because we're not just thinking about an isolated component and a different way to do things within it anywhere in your tree. We're thinking about the root of your app and how it sends data and updates through your entire application. It's a fundamental change in how we do this stuff. Let's say we have the following component tree: app, header, article, hit counter, discussion, comment, comment. If all of these were server components, it would make sense. But let's say article component owns the hits state. Article is use client, and this has the use state call in it. And then hit counter is a sub component. See the issue? When article renders, any owned components will also re-render, including hit and discussion. If these are server components, though, they can't. The React team has added a rule. Client components can only render other client components unless you pass a server component as a prop, which we'll get into in a bit. For now, assume this is true. There are catches, but this is true. One of the biggest aha moments I had with server components was the realization that the new paradigm is all about creating client-server boundaries. Yeah, I push this really hard. It's all about the boundaries and the relationships between components. It lets you control the boundaries of your components, similar to how hooks let you control the boundaries of your state. So here is a client boundary because this is a use client component. So all of these are client components because they're mounted by a use client component. When you add the use client directive to the article component, we create a client boundary. Yep. When I first learned that client components can't render server components, it felt pretty restrictive to me. What if I need to use state high up in my application? Does that mean everything needs to become a client component? Turns out in many cases, we can work around this limitation by restructuring our app so that the owner changes. I'm going to do a quick demo because this doesn't show some of the things I want to show. Here's our hello world. Make a component. And in here, in this components folder, we'll do counter.tsx. First thing, use client. Use client because it's going to have state in it. Export const counter. Give it some hints. There we go. So now we need to mount this in the server component. So I will pass this here and import. And we have this. And it works as expected. We click it and it goes up. But let's make another component quick. We'll do a server only.tsx. Export async function some server component. And in here, we want to do something async. What I'll do is make a text file, text.txt. Make sure it's actually in the root. And I'm going to put hello world from file in here. So I'm going to prompt first read from text.txt with node fs. Well, sure. Return div text. Cool. This should work. I could just import fs the normal way. Import fs from fs. That's not even async. Whatever. This will do what it needs to. So if I throw this in here, we would all expect this to work. And it does. This is now reading from a file, and this is happening on my machine because this text file isn't being bundled. So if this can be accessed, that is happening on the server. So that could be a database call, it could be anything else, but here I'm mounting that there. Let's say I want this in this component though. Like I have div class name equals flex call bg gray 400 or 300. Cool. I'm just going to wrap this like this for now. HTML is hard. Cool. So now this is gray. Where's that semicolon coming from? Oh, here. And I'm going to give the button some class names clicked too. Cool. So here's the button, but let's say we want more space around it and we want this text above in there, P6. So let's say we want the text instead of there inside here. Let's try it. Let's just mount it. Some server component. Okay, cool. We're mounting this in here. Oh no, can't resolve FS. What's happening here? Well, it's trying to render this server component on the client. It's trying to bundle this and then send that as JavaScript to the user that they can run. And they can't. But I want this here. How do I get this here? Well, I'll show you. We will pass it a child. The smart enough, come on. React element, make it optional. This can't run on the client. We can't mount this directly in a client component. The key word there, though, is directly. So I can render any React node as a child, or it could be another prop. I don't even need to name this children. It could be anything else, but I can pass that node as a child. So let's do that. Counter. And now it works, because this server component is still being rendered on the server. When you pass this as a child, it's still being rendered here. But React is now smart enough to know if you're rendering a server component as a prop to a client component, that it should run that on the server and serialize the thing it's passing. So this component doesn't get another JavaScript component to mount. This component is receiving a property of some server component. I found this can sometimes be easier to understand if I change it to something like some sub component. So this is just named whatever you want. The reason I'm changing this so I can show it this way, because I think this helps people understand the difference a little bit better. Oh, I forgot to save. There we go. The point I'm trying to make here is, as long as the thing that does this call, that actually puts the brackets around your server component, if that happens in a server component, you're good. Even if you're passing that as a property to a client component. And this allows for some really powerful weaving of these things without compromising on the core value of server components, which is nothing comes from a use state call. Nothing comes from a hook. There cannot be a hook above a server component that passes props to a server component. Every server component has to be renderable on server in that first pass. So every piece of data it needs to be there as part of the request. So it can come from your cookies. It can come from the URL headers and parameters. It can come from parts of the request and characteristics of it. It cannot come from a component and the state on the client side specifically. This pattern is really cool. I see why he didn't include it as early, because this is where like the mindfucky exploding stuff starts to happen, but it is so powerful. It's so powerful. Let's go back to the article, because I'm almost certain he's going to touch on all of this. Peeking under the hood. Let's look at this at a bit of a lower level. When we use a server component, what does this output look like? What actually gets generated? We run this function. In the React server component paradigm, all components are server components by default. Since we haven't explicitly marked this as a client component, it will only render on the server. So when we visit the page, we receive HTML that looks like this. It has hello world, and then a baked in script tag that basically tells React where all of these things are, so it knows how to update it if it gets new changes in the future. He's restructured things here. The true generated JS inside of an RSC uses stringified JSON as an optimization to reduce the file size of HTML. Yeah. He also stripped out non-critical parts of HTML. Yeah. But this is a really good sample of effectively what you get back from that really simple example. We see that our HTML document includes the UI generated by a React app, the hello world paragraph. Below that, we have the script tag that loads the JS. That's so it can hydrate and other client components can run on the client side. And then we have the script with this inline JS. What we're doing here is telling React, hey, so I know you're missing the homepage component code, but don't worry, here's what it rendered. This allows for React to hydrate and know what is where without having to actually have that code to rerun in full. So this is what each of those server components returned in its props, so that React's traditional virtual DOM model can still have what it needs to mark each component and where it's from and what it has, without having to send you all of the JavaScript to rerun that on your own side. We send along the rendered value the virtual representation that was generated on the server. When React loads the client, it reuses the description instead of regenerating it. Very handy. A fun comparison for this is something like if you do a use effect that has a fetch call and you theoretically got that to run on server. In order for the client to hydrate, it would have to make that same call and you have to wait for that additional network round trip in order to have the same state on the client as the server. Another problem that I'm sure we've all had, the dreaded hydration error, HTML doesn't match. One of those common cases I have for that is date times. If we render on the server, and when we render on the server, the date time it renders is UTC, and when I render it on client, it's PST, then we get two different strings out. It might be 4 p.m. in one time zone and 6 p.m. in the other. So if we run the same JavaScript on the server and the client, the output might be different, which causes a hydration error. But if we don't run that JavaScript on the client, we just pass the returned value to the JavaScript, it prevents those types of hydration errors and desynchronizations because the code only ever has to run once. Yep. Okay, let's see what the advantages that he lists are. React Server Components, this should be R, is the first official way to run server-exclusive code in React. As I mentioned earlier, though, this isn't really a new thing in the broader React ecosystem. We've been doing things like this since 2016. The big difference is we've never had a way to run the server-exclusive code inside our components. This is the magic. Being able to await a database call or a file read from the server, or just calling something like Redis directly. It's really powerful. Oh, he does have the before and after for this. So yeah, here he shows the page interactive time goes down a good bit. It's maybe less exciting because most next apps are already fast enough with page interactive timing. Here's something I find really cool though. We no longer have to make the same compromises in terms of features versus bundle size. It's a very fair point. Your bundle size is no longer going to be as affected by what you're including in a lot of places. Here's a fun one. In upload thing, we have different patterns that are not generated, but we have a set of SVG patterns and colors that are randomly selected based on the name that you chose for your app so that you can have a visual distinction between your apps. We just thought it was a cute thing to make your dashboard a little clearer which app is which. If we were to bundle all of those SVGs, that file would be like 500 kilobytes. And we put them in the JS because we want to be able to dynamically affect values like the fill color. So if we were to have done this traditionally with client components, we would have ended up fetching so much JavaScript we didn't need because we would have had every single SVG that could be rendered on the client as part of that bundle. But since these SVGs are actually server components, you only get the ones that are rendering on your page. We would have had to do some crazy stuff to get this to render correctly so that when you first load the page, it comes through and doesn't have to fetch these images in the background or something because we include them in the markup because we can do that without exploding our bundle with server components. That's just one of many examples of things that were surprisingly easy for us because we're using the new model. Somebody said React's had lazy loading for years. That's not lazy loading. Can I ask you sincerely, like what's not clear so I can clarify it? This isn't lazy loading. There's nothing lazy. I'm Command-Shift-Ring right now. This is a full refresh with no cache. And this content is here. This is in the HTML. This is an embedded SVG. This isn't lazy loading. This is there on the first render without having to fill up the JavaScript with a bunch of stuff. The SVG, this one is there as JSON, but I have 50 SVGs. I have a bunch of SVGs. Can I explain this more? Sure. I'll explain this more. Okay, let me pull up the code quick. Here's the thing that you couldn't do before. See this function, get random pattern styles? This function is in a 500 line of code file full of these different SVGs, all as JSON. This is a shitload of code that I would ideally not ever have to send to my users. This one's even string escaped in a way that my editor doesn't seem to like much. Whatever. This file is huge and it sucks. But I don't need the content of this file. All this file does is defines this SVG. That's all it does. So now, instead of having to load this whole file, or people keep saying, what about code split? What about breaking it up? Cool. I could have made a different file for every one of these SVGs. I could have made a dynamic import structure that will import just the ones that are rendering right now. And then when the page loads on the client, what I'm going to have to do is load the page with no SVGs. Load the JavaScript that determines which SVGs to load. That JavaScript goes and dynamically fetches the however many SVGs I need. And then finally, 5 to 10 steps later, I can finally render the SVG. Or, I know that this is crazy thought, absurd. What if it was just there in the HTML? What if I didn't have to have 15 steps between the JavaScript rendering the SVG and the HTML having the SVG? What if I didn't have to build a new import solution. What if I didn't need 15 layers? And instead, the server code, which the server has a lot of code, it can have as much code as it needs because it's a server, I don't give a crap. The server runs this huge file. It picks the pieces from that file that are needed, puts those in the markup, and now it's done. It doesn't need this code file. It just needs 2 of the values from this code file. Thank you, Prime. I'm very happy you're here because this is one of those crazy like horseshoe theory things where like the heavy front-end people and the heavy back-end people, we all get why this makes sense. I think I've been very clear with this. It seems like SVGs are triggering people. So I'm going to be very clear about something. SVGs are text-based markup. Like this is HTML. You shouldn't have to re-encode this. Like, okay, somebody's upset because this means you have to reload the SVG. Yes, you have to reload the 50 bytes. Correct. It's a really simple example, but let's say you have a heavy component. There's a lot of stuff for UI, but only renders like a little bit of it. I'll make a really simple example. Let's make a component named heavy.tsx. Export async function, some heavy component. And this takes in a prop. If not, props.is signed in, return div, please sign in first. And then after here, we return div, pretend this component has a bunch of stuff that is megabytes of JS. Bad. So in this component, if the user is not signed in, we get this tiny bit of HTML back. If the user is signed in, we could get like a bunch of subcomponents that are really heavy. We could get any of many different things. Could even be like we do a long waiting async call here. There's a lot of things you might want to do later. Somebody said, why not code split that? Because then you have to load another JavaScript bundle. Okay, I think this is where things are breaking down. Let's pretend this was lazy loaded. So we have some const fake lazy equals react.lazy. Doesn't exist, pretend it does. So let's say we do this. Here is how this would work on server to client. So step 1, server sends client empty HTML with JS tag. Step 2, client parses HTML and fetches JS. 3, client runs JS to determine what to render. Step 4, client fetches additional data, JS, or whatever else it needs to complete render. 5, your page is rendered. So in the case of lazy loading, what happens here? Step 1, we get the empty HTML with the JavaScript. Step 2, we load the JavaScript. We load a small bundle of just the things that are above lazy loads, the root JavaScript. The client runs that JavaScript, including running this check in some heavy component. If you're not signed in, then we render this. If you are signed in, we return fake lazy. So here's where things get problematic because now there's a break here where I now have to specify 4.1. Load lazy JS 4.2, run lazy JS 4.3. Hope it doesn't depend on more lazy JS 4.4. Realize it does. Load even more JS. On and on and on until eventually you have everything you need to finish your page render. Because of this, what you'll usually end up doing is putting a suspense around it with a loading state. So as we wait for all of that additional JavaScript to come in, we have a fallback equals div loading. Forgot to import suspense. So now we get significantly more back and forth between the server and client. We have to have an additional loading state to wrap the thing being loaded in lazily, or it's going to block render entirely. And we have to fetch all of this additional JavaScript and parse it just to put a thing there. With server components, you don't have to do any of this. So let's redraw this with server components now. Step 1, server gets request, runs React code to generate HTML. Client renders HTML with correct content, fetches JS to hydrate. 3. Before, we had a whole bunch of steps when we broke out a lazy loaded thing with loading states and all these other pieces in order to make sure we're not sending a bunch of JavaScript to the client that they don't need. Now, if they don't need the client JavaScript, they just don't get it. We just render the right thing on the server and just send the correct markup. If you only need the JavaScript to render the right markup, that doesn't happen anymore. We don't have JavaScript that includes 500 SVGs in it. We just include the SVGs in the HTML. It's really cool. For most projects, it's fine if it takes a few seconds for React to hydrate. Yes. And again, to the point I was making before, if we're waiting the few seconds for React to hydrate, that's time where we're not seeing the SVG if we lazy loaded it. Anything that's under a lazy load doesn't appear until the project has hydrated. That's a huge cost. And if you're willing to block every asset in all of your pages, sure. But the point here is I didn't have to write any special code. I wrote the obvious code when I did this for the upload thing code base. We took all of our SVGs, we put them in a file, we added a function on the bottom that randomly selects one and a color based on the name of your project. Like, this doesn't get included in the bundle because it doesn't need to. It's really nice. But here's something I find really cool. We no longer have to make the same compromise in terms of features versus bundle size. Yeah, you don't think about this. If it's a server rendered component, you don't have to worry about these things. You just render it on the server. Prism is a fantastic example. Prism is a massive library. And if you're using this in pre-React server component land on like Next.js, you're going to end up in a slightly rough spot where you have to wait for all of Prism to load on every page. Even if you lazy load it, you still have to wait for it to load on pages that use it in order for the hydration to be completed. Proper syntax highlighting library with support for all popular languages would be several megabytes, far too large to stick in a JS bundle. In order to make this work, we had to trim out languages and features that aren't mission critical. Oh, that's really cool. Somebody made a new code syntax highlighter just for this. I'm sold. This is the sort of thing that gets me excited about server components. Yeah, absolutely. Something we're excited for in the future with upload thing is the ability to get all of the traits of an upload. So like, what types of files does it allow? How big of files does it allow? All baked in that first server render. So your upload button appears immediately with the correct expectations and behaviors. All data that it fetches from the server based on your API keys. This is all stuff that's entirely doable using these new models. This is a really cool library. And it's one of my favorite examples so far of like why this model is so powerful, because you don't have to worry about how big the server-side bundle is. You just render it on the server. It's not about performance and UX either. After working with RSCs for a while, I've come to really appreciate how easy breezy server components are. Yep, this is the thing I think people miss. We do have more things in the new model. This is the problem space of a React application. I'm going to call this use effect. We'll say this is context, a much smaller one here. And I'll call this one use state and other simple hooks. So this is obviously not all of the complexity of React. There's a lot of other things you have to be considerate of. So let's say horizontal is complexity to understand and vertical is complexity to debug. I'll even call this like foot gun-iness. With core React features, how hard is it to understand the thing and how much can it foot gun you? And this is with the old React model. The foot gun index, yes. I think this is where people get frustrated. On one hand, all of these things still exist, but we're looking to say async components as like the first piece. These are still complex to understand if you're used to the old model, but they're not too complex to understand. But where things get really magical is how hard they are to debug and how foot gunny they are. There's still the foot gun that if you render them on client, it can do some weird shit. But generally, the foot gunniness is significantly lower. But we don't just have async components. We also now have to deal with the concept of a server component as a whole. And server components, again, like take a bit to understand. I'd say about as long as it took me to understand the basic hooks like use state. The foot gunniness on this is even lower. You can do client component. This will be like the same, but slightly bigger. Because this is the thing that we're used to, but the use of the word client and the breakdown of the relationship there is not the most intuitive thing. Passing RSCs to client components. This I'd say like it's complex to understand, but there really isn't too much foot gunniness with it. So what's happened here is we have spread out horizontally to the point where we have slightly more things to understand, but there is so much less foot gunniness now. This is the difference I really have been trying to highlight, is the likelihood you blow your foot off with the new model is significantly lower. And even if the amount of complexity you have to understand to jive with this model is higher, you can compose these pieces in a way that ends up being less complex almost always. Because chances are you're not touching all four of these things in a given feature. If I'm adding a new component that renders user data, I'm probably just using these two. And then if I want to have a button that has an on-click behavior, that requires me to understand some of this, but probably not even all of it. And I probably don't need to touch this part at all. The result is that for most features, most changes, most of the work that you're doing with this model, the amount of complexity you're facing every day, and more importantly, the complexity of debugging and identifying and fixing issues is exponentially smaller. And that's why this model is so cool once it clicks, because things are so much easier to reason about. Yes, there are more parts, and people don't like when this horizontal gets longer because it makes them feel left out. It makes them feel like they have to work harder to be where they were yesterday. And people don't like when the bar gets raised without their permission, especially if they don't see the benefit. But they're so focused on this horizontal complexity of just the number of things they have to know that they're forgetting about the vertical complexity of how much it sucks when the thing doesn't do what it's supposed to. This is the magic of the new model. I'm pretty much entirely agreeing with Josh. It's not about performance in UX, along with, ultimately, still very early days, only emerged from beta a couple months ago. So really excited to see how things evolve over the next couple of years. Community continues to innovate solutions like Bright, take advantage of the new paradigm, etc. This is what I was waiting for. This is when the new model gets way cooler. If we go back to the lazy stuff from earlier, this kind of is like, this is a replacement for the lazy loading patterns that is comically more performant because we don't have to do multiple trips to the server to get data. So we get the first paint as soon as we send something. So we can render the shell, send that, and then start the query after sending it. How can we do that? We already sent this. Don't we have to do a new request? No. HTML streaming comes in clutch here. We'll get into that in a bit. It's beyond the scope of the tutorial, but you can learn more about this stuff on his GitHub. Oh, he doesn't actually show it in here. So here is the diagram Josh drew, and we're going to make it a lot worse. First, we're going to do the lazy loading model. So here, server sends HTML, and client renders HTML, fetches JS. And this part can be an unknown amount of time depending on how fast their network and their device is. And then after we've done that, we have to parse the JS, run JS, determine what else is needed. And let's say at this point, we determine that we need one more JS file and one more API call that then requires another JS file. So let's say we'll just do the lazy load then API. We determined we need another file. So we'll go to the server again, return lazy JS file. And there's some time between these because there's network time. And then run query, determine what else is needed. And we realize we actually need to make an API call. We do this API call, which is actual work that has to be done. And the server respond to API call with data, which might take a bit. Or we'll do a query here. So parse request, and then we have a separate like database query step. We'll make it blue. I'm just using blue as work. DB query, and then parse response, render correct HTML. This is an example with a waterfall. If you're not familiar with the term, waterfall means something that takes time triggers, completes, and then something else that takes time triggers from the completion. So in this case, we ran the JS on the client once it fetched. We realized that it mounts a component that needs more JS that's lazy loaded. So we get that lazy loaded JS. It comes in. We realize that we actually need to make an API call using that JS. So we make the API call. We parse the request. We get the DB query run. We get our response. And then we send that to the client, which then has to parse it and then render the correct HTML using React. So the code for this would be pretty simple. That's some component does a query, fetches some stuff. I forgot a string close there. And we return div data.name. We don't want to load all the JS for this. So instead, we grab it lazily. So the page loads, it renders lazy some component, which then triggers the JS fetch. So the HTML was sent to the user. It has nothing but a JavaScript tag in it. So we load the JavaScript tag, which has this in it. We run the JS. We determine that we need to lazily load this. So we go to the server, say, hey, we need this additional file. The server sends us that additional file. We now have this JavaScript to run. So we run it. We realize that it's missing this data because of this useQuery call. So we run that fetch call after we loaded that additional JavaScript file, and then we return the HTML then. But we have to wait for the server to parse our request, run that query, and then send the response. So I don't think that's ideal. Let's look at the new model quick. This is where streaming comes in. First off, this determine what else is needed shit, that's not a thing anymore. Most of that doesn't exist anymore. The return lazy file doesn't exist. The parse request doesn't exist. I guess it kind of does because it might be data from the cookie. So let's say we immediately respond with some static HTML or whatever our like top level is, and then we stream in additional stuff after. We can identify user here. Fetches JS. I should say renders HTML skeleton. And I'll say sends HTML skeleton here. And while that happens, this is all happening in the background as the user renders this content. And then when this query is complete, we can even say it takes longer than it does. It will then stream down the additional data as part of the same request. That is, render complete page. So we get that skeleton almost immediately, the same way we did before. After sending that response, we can keep running these things in that same server node in the background. And once that's done, we send a new response with the additional data. It's so much easier to manage. I can show what this looks like if you're curious, because it's actually pretty easy to do. Instead of counter, let's render some slow component. So we have some server component. We're going to change this, or I'll just export async function, some slow component. Perfect. If I mount this component and pretend again that this promise is something that work that your server is doing, it's a query that you're doing, it's data you're fetching, it's something meaningful. I'm just doing this because I'm lazy. And we go in here and we render this. In fact, we can even leave some server component here. So I render that and then we render the slow component. If we go to my localhost, what you'll see is the page is taking 5 seconds to load, but it has all of the data in it immediately. But what if I wanted the user to get hello world from a file before they got the slow component? What if I wanted you to get this first, have a loading state for this, and then this comes in? That is now trivial because we can use suspense for much cooler things than lazy loading. I can yoink this, fallback equals div doing work, and now the page loads immediately. I refresh, page loads instantaneously. You can see the loading spinner still going because the main HTML response is still streaming down, but we have content rendered that's meaningful. And we look at the network tab, so you can see that the response initially has different content that it ends up with because with HTTP streaming, we're able to send part of the response and then send the rest later. This means if you have a bunch of React components on your app, most of which load very quickly, but you have one that you notice the data takes a while, you just wrap that in suspense and you're done. This was never this easy to structure before, where the thing you do by default is really simple, it works really well, and as soon as you notice something is slow, you wrap it in suspense. And you're done. It's so clean and simple and easy to work around. And the result is significantly more performant because you're not waiting and doing a bunch more back and forths. I saw the question coming up a few times. Isn't this more work for the server though? Fuck no, it's absolutely not. Because previously, I'd respond from a server to send the HTML. The client would run some stuff. It would go back to the server and say, hey, I need more JavaScript. The server would process that request and respond with more JavaScript. Then the client would run that JavaScript, realize it needs to make an API call, and go back to the server and say, hey, I'm sorry, last time I promise, just give me my JSON. The server processes your request again, generates a new response, and then sends that new response. And then now the client has the response. With this model, you process one request. You don't parse additional headers you don't need to. You don't terminate more responses than you need to. You don't spin up more lambdas than you need to. Well, this is a DB call too. And if we assume that these DB queries are the same size, which, like, let's be fair, the one for the API is probably bigger because it's overfetching. Do you see how much less work has to be done on the server than has to be done here? Yes, any one of these blocks is smaller than the block here, but we're not talking about the number of blocks. We're talking about how much work is done total. And if you look, all of these certainly add up to be a lot more than the one request response process here. The only reason this would be slower is if for some reason HTTP streaming was significantly slower, which it isn't, or the code that turns your JSON into HTML is particularly slow or compute heavy, which it isn't. Doing one pass with something like React to take a bunch of data and turn that into HTML is really fast. Those aren't real costs. Yeah, I don't buy the argument that this is more expensive. It isn't. You end up making so many fewer API calls that this ends up being significantly cheaper. And I can promise you, as someone who's built apps on both, the amount of time of compute that each of these is using per user, way less server compute is running on the new model, almost always for me. I think this makes it very clear how much better the new model is. I should draw some arrows to make it clear that that response becomes the content. But specifically, the server can send a response, keep doing work, and then send more response later. And all you have to do as a dev to consume that is wrap the slow thing in suspense. This doesn't change when this code runs. The slow component still runs as soon as the page load starts. So it's just better. That ended up being a lot more than I expected, but I think it communicates a lot of the stuff I've been trying to. Server components are a fantastic model, and I think if you take the time to dive in and understand, you'll be really impressed with what you can do with them. Thank you, Josh, for the wonderful article. Thank you, Agor, for recommending it to me on stream. And if you want to learn more about why I love this so much, I'll pin a bunch of videos on the side here, all about my favorite parts about server components and some of the cool things they changed about my thinking. Thank you guys as always. Really appreciate it. Peace, nerds.